Hello, guys. Thanks for putting up with my blanking out in class on Friday. This is problem number 8 that I was trying to do. It wants to know the velocity, which is the first derivative, of the particle at the first instance. The particle is at the origin. Well, that means the first instance that the particle is at the x-axis, because the origin for that means that the particle has gone back to 0. So what it really means algebraically is this. It means where is the particle equation equal to 0? And I had started to do that in class and got a little sidetracked because when I looked at the graph, what you're seeing here is it sort of looks like it goes through the origin. And it didn't make any sense to me that time would be equal to 0. So that's where I kind of got hinged up. But I got over that because I knew I had done something else prior when I had done the problem. So I'm going to zoom in here. I want to show you that it's not exactly crossing at the origin. It's crossing right there. That's the first time where t is greater than or equal to 0 that the particle is at the origin, or x of t equals 0. So, I can hit my trace button. I'm not going to get exactly that value because it'll either be a little above or a little below just by using the trace value. But it's a good estimate. How can I do that exactly? Well, the calculator does it by clicking second, trace 2 for 0. And we want to move our boundary a little to the left. You can see the little blinking cursor and hit enter. And we want to move our boundary a little to the right of that point and hit enter. And then, of course, we do not want to guess. We could have done that earlier using the trace button. So hit enter one more time. And it's going to give you x equals, and I'm going to write that whole thing out, 64514. X equals 0.178645514. Okay, so what that represents is actually t. So let me fix that a little bit, just so it makes more sense in the context of the problem. So this is the time that we're interested in. We want to know the velocity. And notice I'm keeping all those decimal places for the moment. AP only requires 3 decimal places. And that's going to be the same thing as x prime of 0.178645514. Now, I can do the derivative the way I did in class. Not a bad thing. I can also get my calculator back, and I can calculate that directly in the calculator. The way that I do that is by using second, and again, we're going to the trace button, the calc menu. And if you look here at option 6, we have dy dx. That is the same thing as the first derivative. So we're going to select 6. Now it's going to show you all this junk, but you want to enter point, all that junk, 1, 7, 8, and I'm going to enter in all those decimal points so that I get as little rounding as possible. And what this is calculating is the derivative at that time. And I get 5.153. Which looks to be choice D. So again, my apologies for class on Friday. I just looked at the graph and kind of froze up because this number, the 0.178, is so close to 0. I just got